What you see on this slide is the 4-stroke cycle, which is a commonly used diesel engine on an automobile. The first cycle is called the intake stroke. What happens in the intake stroke is that, so during the suction stroke, the intake valve remains open during the entire intake stroke. That means the piston moves from the top dead center to the bottom dead center. Due to the partial vacuum created by the piston travel, air rushes in. The air rushes through an air filter. So you have air cleaned up through the filter passing through the inlet port. During this stroke, the exhaust valve remains closed during the entire period of the suction stroke. At the compression stroke, both inlet and exhaust valve remains closed. The piston travels from the bottom dead center to the top dead center of the cylinder. The entrapped air is compressed, causing air temperatures to rise above 560 degrees. At this temperature, the fuel is injected in atomized conditions into the hot air where it ignites. Combustion of the fuel generated heat and gases. The rapid rise in temperatures and pressures in the combustion chamber pushes the piston to bottom dead center. And then we have the power stroke. At the power stroke, due to high temperatures and pressures in the combustion chamber, piston is pushed from the top dead center to bottom dead center. This is also called as useful work done or the power stroke. During this stroke, both the inlet and exhaust valve remains closed. And then we have the 4th stroke, which is the exhaust stroke. During the exhaust stroke, intake valve remains closed. Exhaust valve remains open during the entire stroke. Piston travels from the bottom dead center to the top dead center and exhaust gases are expelled out. At the 4th stroke, which is the exhaust stroke, we have a valve overlap period. It's during this period when the exhaust stroke is coming to an end, the intake stroke is commencing. Both the intake and the exhaust valves are open. This is essential for the 4-stroke cycle of the combustion engine. It allows air to rush in from the intake port and forces any remaining burnt gases out of the exhaust port in a scavenging operation so that the combustion chamber is clean and ready for a fresh charge of air. It also cools the exhaust valves and the piston crown, which is subject to high temperatures.